Is it appearing on my screen?
Yes, sir.
Morning, good morning. So this is the problem. Draw full size cam profile with a roller of 25 mm diameter. Roller follower is given of 25 mm diameter attached to the follower to give a lift of 35 mm. It means stroke length is given 35 mm and axis. What happened, Sharik? Is hello? Is it visible my screen?
Visible.
Axis of the follower is offset. Axis of the follower is offset to the right of the cam axis. To the right of the cam axis. Cam axis by 18 mm. Ascent of the follower takes place with simple harmonic motion. So here simple harmonic motion type is given displacement diagram in 0.05 seconds followed by a period for rest 0.125 seconds. The follower then descend with the uniform acceleration and retardation motion. So in this type of problem, the displacement diagram contains the two types of motion. One is the simple harmonic motion, one is the uniform acceleration and retardation. Simple harmonic motion simple harmonic motion for the first stage, uniform acceleration and retardation for the third stage. First stage means rising period and third stage is the falling period here. The time is given 0.125 seconds and the remaining period rest at the minimum lifted position and acceleration is being 3 by 5 times the retardation and cam rotates clockwise direction at a constant speed of 240 rpm and the base circle diameter is given. So here asking to draw the full size cam profile. So to draw the cam profile first we need a displacement diagram. Okay, first write down the given data. Given data. So what is the given data here? Roller diameter is given. So roller diameter 25 mm and follower is stroke length is given S value 35 mm and offset circle offset value is given. Offset value is 18 mm. Okay, and then ascent time is given. Ascent value is given. How much? 0.05 seconds with simple harmonic motion. With simple harmonic motion and followed by period rest, that is dual period. How much? 0.125 seconds. Okay, The next one, descent period. Descent period 0.125 seconds with uniform acceleration retardation motion. Okay, and then remaining last period is the dual. As usual, dual is the remaining period. Okay, remaining period we don't know, is given like that. And acceleration given, acceleration is being 3 by 5 times the retardation. The relation is given. So this relation is referred to, this relation is refers to this diagram, uniform acceleration and retardation. Okay, this relation is help to construct the displacement diagram with help in the uniform acceleration and retardation motion. Okay, and the clock is cam is rotating clockwise direction. The speed value is given how much, 240 rpm, speed value of cam. So cam is rotating in a clockwise direction, with a speed of 240 rpm. That is the meaning. And base circle radius is given, base circle radius value is given 50 mm. Now to draw the to construct the displacement diagram, we need the angle of rotation of the cams. So if we know the angle of rotation of cam, that angle we are going to converting into centimeters, isn't it? So for that, what we are doing in the problem, what is given, ascent point means rising period. Ascent means rising period is given 0 in terms of second. Dual is given in terms of second. Descent means returning position is given in terms of second. So these seconds we need to convert into degrees. Okay, so to convert the degrees, first start with the speed of the cam, motion of the cam. Speed of the cam is given revolution per minute. So that revolution per minute we need to convert first revolution per seconds, RPS. To convert the RPS, just divided with the 60 seconds. Okay, so it is converted into RPS. Now this RPS we need to convert into degrees per second. Degrees per second. In this we need to convert. So to convert that, what we need to do, 240 by 60 into 360 into 360. So now it is converted. So this total value is in terms of degrees per second. Nothing but this is a motion of the, this is a nothing but motion of the cam. Okay, that motion we need to describe with the these 4 periods. The motion of the cam we need to describe with these 4 periods. So what are those? First one is the ascent. Ascent is 0.05 seconds is given. So the seconds we need to convert. So if we need to convert means 0.05 into how much this value, 4. So 4 into 360. So how much this one, 4 into 360, 72 degrees. 72 degrees. So what is the meaning of 72 degrees? It is the angular displacement of the cam during first period. What is the first period? Ascent period. Angular displacement of cam during first period. A during ascent period. So this is the first one, nothing but rising period. Now second one is a dual period. The second point is given dual period. So the dual period also, we need to convert that. How much given? 0.125 seconds given. So we need to multiply this value here. We need to multiply this cam rotation here, 4 into 360 degrees. So how much this value? How much this one? 18 degrees. 180 degrees. So dual period for the cam is 18 degrees. Now calculating the descent value. So that one, angular displacement, angular displacement for cam during descent period. Descent period. How much that one?
सर
Yeah.
सर वो आरपीएम को आरपीएस में करके फिर डिग्री में क्या करे समझ में नहीं आया
RPM first I converted RPM into RPS. This one.
वाई सर
Then then this one converted into degree per second. Degree per second means multiply with the 360 degrees.
so why did we do that sir because till now we did not do
Because
that
because here RPM revolutions, we are describing the per minute revolution of the cam per minute you are describing here. That if you explain in terms of seconds, so revolutions per second you described here. Now this one is the revolutions. In terms of revolution means circular motion you describing here. So I want in terms of degrees, so you multiply with the 360 degrees. For continuous circle motion that takes place total 360 degrees. So you want to show in degrees, so multiply with the 360 degrees. So to get the value of the cam rotation in terms of degree, I am multiplying with the 360. So this total product is known as a motion of the cam. So particular period, if you multiply this value, particular period means ascent period, descent period, devel period. So particular period, if we multiply this value, if you multiply this value for the particular periods here, you will get the particular degree value. Okay. So here 0.125 into 4 into 360 degrees. So how much this one? Uh, how much this one? 180 degrees. So 180 degrees we got. So this is nothing but return period. Descent nothing but return period. Ascent nothing but a rising period. This is a ascent nothing rising period. This is a descent nothing but falling period. This is the dwell period. So actually we have 4 periods. So here we don't know this period value. So to know this period value, total 360 degrees minus how much ascent period we got 72 degrees. Rising dual period how much we got 18 degrees. And falling period how much we got 180 degrees. So like this if you do, you will get the falling dual period how much total is, wait I'm doing total 360 minus 78 plus 18 plus 180, 276 minus 360, it is 84. Last remaining is 84 degrees. So we got the values. This is the first ascent period value, we got 72 degrees. Then we got 18 degrees. Then this is how much 180 degree. Okay, I think let me check once again. 72 plus 18 plus and 180 minus 360. Sorry, it is 90 degrees, not 84. It is 90 degree. This is 90 degree. So all values we got. Okay, now so I'm drawing here displacement diagram. So rising period, first period rising period value we got as a 72 degrees. So convert the 72 degrees into centimeter. So to convert it, what is the procedure? I said 72 divided by 20. It means for 20 degrees I am considering as a 1 centimeter. This is my assumption. I said in a previous class 20 degrees 1 centimeter I am considering. So for 72 degrees how many degrees? 72 by 20, 3.6 centimeters. 3.6 centimeters. Now what is the second period? Second period, dwell period, 18 degrees. So how much centimeter this one? 18 by 20. So how much this one? 18 by 20. 0.9 centimeters. Then third one is a falling period. How much we got? 180 degrees we got. So 180 means 180 by 20, 9 centimeters. 180 by 20, 9 centimeters. Then last one is the fourth one, 90 degrees. So for 90 degrees, how much? 90 by 20, 4.5 centimeters. So by with this help with these values 3.6, 0.9, 9, 4.5, with these values construct the displacement diagram. So measure 3.6 centimeter. So by measuring the all values, I'm directly drawing here. Okay, 3.6 centimeter. Measure on the scale and put a point and draw vertical line. Rising period, for the rising period I'm drawing here. So what is the length here? The length is uh, 72 degrees. Don't show on the displacement diagram like a 3.6 centimeter, 9 centimeter, 4 centimeter. Don't show the linear dimensions. Show with the angular dimensions. Okay, 72 degrees. Now divide this into 6 equal parts. Divide this one into 6 equal parts. 1, 2, 3, 4, 5. Okay, then give the names 0, 1, 2, 3, 4, 5, 6. Now the question is what type of motion we need to construct here, because we have the four types of the displacement motions. What are those? Uniform velocity, simple harmonic motion, uniform acceleration and retardation, and cycloidal motion. Among the four, which one we need to construct here?
సార్
Yeah,
అది లెంత్ ఎంతైనా ఉండొచ్చా సార్?
length here, see, measure the length here.
3.6
3.6 from here to here, 3.6.
అంటే ఇప్పుడు తక్కువ ఉంటే సార్, లెంత్ తక్కువ ఉంటే డివైడ్ తక్కువ తీసుకోవాలా?
No, no, no. Here not a matter of length decreasing or increasing. Suppose you want to divide the 6 parts. So 3.6 by 6. How much the value you got? Maintain that equal distance. 3.6 divided by 6. How much? 0.6. So maintain 0.6 centimeter distance. Here to here 0.6. Here to here 0.6. Here to here 0.6. Here to here 0.6, here to here 0.6, here to here 0.6. Like that you need to divide. Okay.
ఓకే సార్.
Now the question is what type of method we need to follow here. So go through the question first. Question is given ascent. Here ascent value means rising period. Rising period is following the simple harmonic motion. So for the rising period, we need to follow the simple harmonic motion method. What is the method? So first we need to construct the rectangle box, then draw the semicircle here. Then draw the semicircle here. What is the diameter of the semicircle? Stroke length is the diameter of the semicircle here. Okay, it means measure the midpoint of this line. Okay, keep the needle of the compass here and select any point end point of this stroke length value and construct the semicircle. Okay, now after constructing the semicircle, divide the semicircle into 6 equal parts, because we divided the here linear line 6 equal parts. So for that reason divide the semicircle into 6 equal parts. How much each distance? 180 divided by 6. How much each line distance?
30.
So total angle is 180 by how many parts we are dividing? 6. So each how much? 30 degrees.
30.
30. Maintain the angle 30 here. Here 30. here 30, here 30, here 30, like that. By maintaining the 30 degrees, divide the 6 equal parts. Okay, now give the naming 0, 1, 2, 3, 4, 5, 6. Okay, so after dividing, uh, draw the horizontal line through this semicircle where these lines are touching on the circumference of the circle. So here the line is touching at the first point. Draw a horizontal line through this first point like this, through the second point, through the third point, through the fourth point, through the fifth point. Okay, now draw vertical lines through these on the horizontal line, whatever the points is appearing, draw the vertical line through these points. So I'm drawing here. Okay, now where the similar points are intersecting, denote that point. Means here the first line is passing, first vertical line is passing here, another horizontal, first line is passing horizontal line here. So both lines are intersecting here. Give that name as a 1 dash. Here 2 line is passing, here 2 line is passing. Both are intersecting here. Give that name as a 2 dash. Here third line, here third line. Give that name as a third dash. This is a fourth line passing. Here this is the fourth line. Both are intersecting here. Give that name as a 4 dash. This is a fifth line. This is a fifth horizontal line passing here. Both are intersecting at this point. Give that name as a 5 dash. Sixth line and sixth line. Both are intersecting here. Give that name as a 6 dash. Okay, after generating the all points, join the all points with the free hand like this. So here answer should be dark. Remember this point, answer should be dark. It means in this diagram, which one is the answer? The answer is the dark line. Don't forget to make the dark this one. Okay, first stage is over. Now come to the second stage. What is the second stage? Dual period. So how much centimeter we need to maintain? 0.9 centimeter. So measure, start with here, measure 0.9 centimeter here, somewhere it is. Now draw vertical line. Okay, now give that name. What is the naming here? This is a dual period. So how much? 18 degrees. Don't write the 0.9 centimeter. If you write the 0.9 centimeters linear dimensions value, easily you will lose the marks. Okay, you need to show the representation here, the representation in terms of degree only, not in terms of centimeters. While drawing the diagrams with centimeter only you need to draw, but while showing it you need to show with the degree values. Okay, now for dual period we need not to do anything. Okay, then what is the third period? Third period is a falling period. So what is the falling period? 9 centimeter. Measure with the scale 9 centimeter and place on the horizontal line. So 9 centimeter measure with the scale, placing here. Okay, now we need to divide this line. Which line? The falling period line. So first show the length of the falling period from here to here. Falling period total how many? 180 degrees. Total 180 degrees. So then what is the next step? The next step is we need to divide this third box. So how much each length? How much each length? That is a question mark here, because sir 9 centimeter means 9 divided by 6 we can easily divide. Your answer is 9 by 6 we can divide, na sir. That is not the procedure here, because see the question here. Question is given, one relation is given. Ascent is equal to 3 by 5 times of the retardation. Means acceleration is 3 by 5 times of the retardation. Okay, so this relation is given. This relation first we need to convert into period. So to convert the period, it is going to reciprocal. That is ascent period equal P, ascent period P equal 5 by 3 into retardation period. Just remember this, blindly remember this relation. Whenever ascent value you are writing in terms of period, just make it a reciprocal of this one. Okay, blindly I'm telling because there is so much procedure is there. So this procedure is not important. Just blindly remember that ascent period, whenever ascent value you are converting into period, nothing but here you need to write the period value. So while writing the period, write this reciprocal 5 by 3 of retardation period. Please mute yourself. Okay, so this one is a procedure. So this is not important for you how to converting this one. So just I'm telling the point. Just remember blindly this one. Now ascent period is equal to 5 by 3 retardation period. Now what is the use of this one? See here, for every cam rotation, for in every stage, one falling and again one rising and one falling period is there. Okay, so particularly the problem mentioning here with in particular in uniform acceleration and retardation, there is a two periods. In retardation, uniform acceleration and retardation, there is a two periods. The two periods are that is ascent period and descent period for this particular uniform acceleration and retardation. So that values we need to know first. So that is okay. So in this period again we have the two periods, that is ascent period and that is one is the descent period. That values we need to first find out. So how much we got ascent period, we got 5 by 3 retardation period. This relation is given in the question. So through this we need to calculate the some values. What are those? One is the angular displacement of the cam during ascent period. Angular displacement of cam during ascent period. So don't go, sir, already you drawn ascent period, already you calculate the angular displacement for the during ascent period. I'm calculating particularly for this third box, because the question itself given the relation ascent equal to this relation is given. If this relation is not given in the problem, directly I'm following this method, because the question is given this relation, so that reason I'm following this method. Okay, now angular displacement
Sir?
of yeah.
सर ascent period तो सर already हो गया ना सर, मतलब वो 72 degrees का, that is also
Yeah,
ascent
yeah,
period only.
yeah. So listen this statement and what I am telling. If this statement in the question, what is the statement here? The acceleration being 3 by 5 times the retardation. If this relation is not given in the problem, whatever the data is there, with that data we are proceed. But the thing is, here this relation is given. Blindly remember this one. Whenever this type of statement is given, this statement is applied to this motion, uniform acceleration and retardation. This statement is refers to applied to uniform acceleration and retardation. It means whatever the mechanism, whatever the numericals you want to calculate, you are going to calculating. These are all things belongs to the this period, uniform acceleration and retardation. So for that only I am calculating again this value, angular displacement of the cam during ascent period, during descent period. Okay, so it means nothing but in uniform acceleration and retardation, the acceleration is 3 by 5 times of the retardation. It means retardation and acceleration both are not uniform for this third stage. For the first stage, simple harmonic motion, acceleration and retardation is same. So here, actually this is the rising period, this is the dual period, this is the falling period, this is the dual period. For this also, you have the ascent and descent. For this also, you have the ascent and descent, because the cams, some types of cams having the irregular surfaces. What type of surface? Suppose here, suppose if the cam is like this. Suppose if the cam is like this, at this time what happen? Sometimes it is going to fall down at this during this period. During this period, the follower is going to rise. During this period, the follower is going to fall down. During this period, the follower is going to fall down. At these situations, you come across a such type of problem. If the cam is having the uniform surface like this, suppose this is a like this, what happens at this time? One is a rising period, one is a falling period. One is a rising period, one is a falling period, like this. Because here uniform surface is there. Here is the surface of the cam is non-uniform. At this situation, such type of problems you will going to face. Now, angular displacement of the cam during the acceleration period, that is, here I'm telling the procedure how to calculate this one. 5 by 5 by, here instead of writing 3, calculate here 5 plus 3 how much? 5 plus 3 8. 5 by 8 into 5 by 8 into what is the angular displacement before 180 degrees, multiply with the 180 degrees. So how much value this one? 112.5 degrees. Now again another angular displacement of cam during descent period. During descent period, that is 5 by 8. So sorry, don't no need to again calculation. Easily we can calculate. Total value is 180 degrees minus our first ascent value we calculated 112.5 degrees. So remaining is the 67.5. This value, descent value, we can also calculate like this. Otherwise, we can also calculate like this. Here 5 by 8 we can taken. Now next time whenever we are taking this 3 by 8 into 180 degrees. First time with the first value, ascent value. Second time we are calculating descent value, take the 3 value. And here the bottom value, whatever you're writing in here, add these two values, 5 plus 3. Okay, for the ascent, top value you need to select here, and for the descent value, bottom value you need to select and write here. And whatever they are writing here, denominator 8, 8 is common. So how you will get the 8 value? By adding this numerator and denominator 5 plus 3, you will get the 8 value. So sir, it is difficulty for us to calculate the second one easily, nothing but from the 180 degrees, if you subtract the first value also, we will get the this 60.7, 67.5 value. Okay. Now another value. What is the another value? Height follower lift during the ascent period. Follower lift during ascent period. Ascent period. So how much it is going to lifted? Again same procedure. 5 by 8 into what is the total stroke length? The total stroke length value given in question 35 mm. Stroke length nothing but this y value, vertical value. Okay, this one stroke length is a this value 35 mm. Okay, so how much value we'll get? We'll get 21.87, 21.875 mm. Okay, now follower lift during descent period. So during descent period, which value we need to take? 3 by 8 value. 3 by 8 into 35. How much we'll get? It is 13.125. 13.125. This one value we can also calculate like this. So this one 21.875 we got. So total is a 35. Total is 35 minus 21.875. If you subtract, you will get the same value 13.125. Okay. Now, so this total procedure, total calculation I calculated here because to divide this third box. To divide this third box. So first ascent period, as per the ascent period, double 1.2 degrees. So double 1.2 degrees convert into centimeter. Double one 2.5 degrees divided by 20. How much it is? Double one 2.5 divided by 20, 5.625. The value is 5.625. So 5.625 measure on the scale from here to here somewhere it is going to located like this. Then draw one vertical line. Now the remaining is how much here to here? The remaining is 67.5. So show that value here again from here to here 2.5 degrees. Now here to here 67.5. Now dividing this rectangle into horizontal one. So how much we need to maintain? First ascent period.
Ascent and descent will be in the same column.
What Amma?
Ascent and descent would be in same column because
Same column. Same column. In this third stage only, whatever operation I'm doing applies to this third column only. And dividing this one. Following the follower lifting during the ascent period. So measure from the first one. The first one measure from the top side. Measure from the top side. Here to here, how much it is? 21.875 mm. So measure on this, convert it into centimeter, measure, it is going to located somewhere here. 21 means somewhere here. So draw one horizontal line. Draw one horizontal line. Okay. Now the thing is we divided as per the calculations. Now from here to here, how much? Separately I'm showing here. Here to here, how much?
Sir?
Yeah.
So always acceleration period should be taken upside, sir.
Yeah.
In the first above half.
Yeah. This one is the 13.125. So remember one thing, Babu, whatever the procedure I followed here, this procedure is particularly applied for uniform acceleration and retardation motion. Remember this one. Okay. Now, first box, this first box, the first line from the here to here, we need to divide 3 equal parts because we are divided here 6 equal parts. It means here 3, here 3, here 3, here 3. Like that we need to divide. So divide here to here, how much equal 3 equal parts? How much here to here? 5.625. So 5.625 divided by 3. How much each value? How much each value? Let I'm dividing by 3. 1.875. 1.875 centimeter. Okay, so each value is 1.875. So here to here 1.871, 2, 3, 6, 5, 4, 3. Here to here 1.875. Here to here 1.875. Here to here 1.875. Okay, now same manner divide this portion also. How much this portion? 67 value we got. So 67, how much if we convert 67 into centimeters? 67.5 degrees divided by 20 degrees. 67 divided by 67, wait, 0.5 divided by 20 divided by 3, 1.125. So if we divided, wait, 67.5 divided by 3, 67.5 divided by 20, 3.375, 3.375, again divided by 3, again divided by 3, 1.125, 1.125. So measure 1.125 centimeter and divide this one also, 1, 2, 3. So here to here 1.125, here to here 1.125, here to here 1.125. So this is the 2, this is the 1, and this is 0. Writing the names is reverse manner because here 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1, 0. Now dividing this vertical line also same manner what you practiced here. So from the here to here divide 3 equal parts, again here to here 3 equal parts. So to divide the 3 equal parts, 21.875 divided by 3, make it, and whatever the value you got, maintain that value here, divide the 3 equal parts. In same manner, here divided by 3, whatever the value you got, maintain that value and divide this part. And give the names A, B, C, D, E, F. Okay. After dividing, the procedure you know. Thing is, join the vertical line from the top to bottom. Join the vertical lines from the top to bottom. Okay. Here join the vertical lines. Join the vertical lines. Okay. Now connect the from this point to E, from this point to D, from this point to C. Now from this origin to C, from this origin to B, from this origin to A. Now here the sixth line, the last line intersecting here, give that name as a 6 dash. Here fifth line, here E line is passing here, give that as a 5 dash. Here it is fourth line, here it is fourth line, give that name as a 4 dash. Here it is third line, this is the third line, give that name as a 3 dash. There B line, here second line, both are intersecting here, give that name as 2 dash. Here one line, here A line, both are intersecting here, give that name as a 1 dash, this is a O. Join the all points by freehand. Join the all points by freehand. By freehand. Now after joining these lines, join these two curves at the dual period. Don't forget to join this one. And at this dual period also, we need to draw dark line. This is the procedure. Any doubts, Babu, regarding this value? Sorry, regarding this problem? If you
So
don't have,
what if he has given simple harmonic motion after uniform motion? How we should do?
your question is after this one, if simple harmonic motion will given, what is how it is appear? Is it? So first draw this figure, then maintain the gap, then apply this diagram. So
So, but you
so
said the condition will be applied for only uniform acceleration retardation.
yeah, this total calculation is condition is applied only for this value. So
No,
whatever
sir.
that
The one
this
condition is given. The acceleration is of 3/5 times of retardation.
so
You
this
said that
value
condition. That
applied for
condition
the
will be applied.
listen, apply this condition, draw this one. After completion of this one, draw this diagram at the end of here. It means the diagram appears like this. See here, I'm drawing separately. The diagram is going to appear like this. First draw this one. This is the uniform acceleration and retardation. As per the calculations, we got like this, and we got the curve like this. Then after dual period, okay. Then after simple harmonic motion is there. Simple harmonic motion, for that, maintain the gap here first, then draw the semicircle, because at the last stage the gap will be present, should be present. But to draw the construct the simple harmonic motion, we require the semicircle. So middle of the diagram constructing a semicircle is not possible. For that, the shift this semicircle to end of the diagram and apply the procedure. Drawing the horizontal line, vertical lines, intersecting points, curve will be obtained like this.
Yeah. After that, we have to rub the dual period lines. No, sir?
Yeah. After that, this is the rising period, this is the dual period, this is the falling period, this is the dual period that we need to show. Now, is it okay with the displacement diagram? If you don't have any doubt, we can move to next. What is that? Cam profile. Is it okay?
Yes, sir.
Now I'm constructing the cam profile.
So, what will happen to the dual period of simple harmonic motion diagram, sir?
For the simple harmonic motion. Sorry, Babu. Please ask again.
So it is
Hello. Hello. Your voice is breaking, Babu. Somebody asking, but the voice is breaking. In dual period, we.
simple
సింపుల్
harmonic.
Hello.
సింపుల్ హార్మోనిక్ మోషన్ ఇంకోసారి చెప్పండి సార్.
Simple harmonic motion, అమ్మా.
అవును సార్.
సింపుల్ హార్మోనిక్ ప్రొసీజర్ నేను ఆల్రెడీ ఎక్స్ప్లెయిన్ చేశా. అది ఆ వీడియో నేను యూట్యూబ్లో అప్లోడ్ చేసా, ఒకసారి చూడు.
ఛానల్ సార్.
ఉమ్.
ఛానల్ సార్.
నా ఛానల్లో ఉన్నది, దాంట్లో చూడు ఒకసారి. టైం ఎక్కువైపోతుంది మళ్ళీ నీకు ఎక్స్ప్లెయిన్ చేయాలంటే ప్రొసీజర్.
Sir, in this problem, sir, we are rising the follower with the help of simple harmonic motion. No,
Yeah.
sir. And then after this, descending the follower in the form of uniform retardation and acceleration, sir.
Yeah. Exactly.
Okay, so they will be a combination. Always they will be a combination of.
It is depends on examiner. They will give a combination, otherwise singular type of motion will be given.
Okay, sir.
Now I'm drawing the cam profile. So cam profile is What type of cam profile is given? Roller follower is given. Remember, whenever the roller follower is given, you need to construct the prime circle also. Blindly remember this point. Whenever roller follower is given in the question, you need to construct the prime circle also. If the roller follower is not given in the question, no need to draw the prime circle, just draw the base circle, that is enough. Okay. Now first draw the offset circle. The procedure, listen properly. First draw the offset circle. Offset value how much given? 18 mm given. Offset value 18 mm given. So measure with the compass. Measure with compass 18 mm and draw one small circle. Draw one small circle. This small circle is known as a offset circle. Okay. Now go to the question. What is the question given? The question is given. It is offset by 18 mm at what side? Right side of the cam axis. Right side of the cam axis. It means this is the cam axis. This is the cam axis passing to the set midpoint. So right side means this side you need to take. Okay, this is the offset. Right side, take right side and draw vertical tangent. Draw vertical tangent like this. After drawing the vertical tangent, nothing but this is the axis for the follower. This is the axis for the follower. Leave it. Then take the base circle radius. Base circle radius how much given in the question? Base circle radius how much given? Base circle diameter is given 50 mm. So take the 25 mm radius, measure with the compass.
Sir, radius
And
only.
this is the radius. Yeah, sorry. Radius of the base circle given 50 mm. So 50 mm measure with the compass and draw another circle. With the center, this is the one. O as a center. O as a center, draw another circle 50 mm radius. Okay. This is known as a base circle. The first one is a offset circle. The second one, larger circle, is a base circle. Okay. Now, because the problem is given in the question, roller follower. For that reason only, I am drawing the prime circle. If roller follower is not given in the question, no need to draw the prime circle. If question examiner asks the to draw the roller, please mute yourself. You people making noise, I don't know. Mute option is not appearing. No. Very weird. No. Very weird. Construction of prime circle. To construct the prime circle radius is base circle radius plus roller radius. Base circle radius is given 50. Roller radius how much? Roller radius, roller diameter is given in the question 25 mm diameter. So 25 means 12.5. So total how much? 50 plus 50, 62.5. 62.5 mm. Measure with the compass 62.5 radius and draw another circle. Draw another circle that is known as a prime circle. Okay. After drawing the prime circle, now draw the roller. So prime circle is become bigger. After drawing the prime circle, draw the roller. What is the diameter of the roller? Diameter of the roller is given 25 mm. So measure 12.5 radius, draw the roller, and draw the follower. This is the roller follower. Okay. This is now after drawing this one. So this is the first point, A point. This is the O point. Connect this A to O. Connect the A to O. Okay. Now go to the displacement diagram again. In the rising period, how many parts you divided? 6 parts you divided here. 6 parts you divided here. So with the 6 parts here, same number of parts you need to divide in this also. So how much degree here? Total 72 degree for the rising period, 72 degree. So measure with the D scale. Okay, from here to here. Suppose this is a 72 degrees. Okay, so this is the B point. This is the A point. This is the B point. Now in dual period, what is the degree here? 18 degree. Here it is 18 degree. So 18 degree is measure with the D scale and measure 18 degrees. Give that name as a C. Okay, then what is the next one is a 180 degrees, last one is a 90 degree. So measure 180. So here to this is 18. Now here to here 180. Here to here 180. This is the D point. Now final is the 90 degrees. सर मैं क्लास में हूँ सर.
हेलो
सर मैं क्लास में हूँ, फिर फोन करता हूँ.
अरे भाई कभी भी फोन कर क्या समझ क्या
मैं फिर फोन करता हूँ. क्लास में हूँ, सही भी हूँ. So like this, divide the all points. Now after dividing, A to B divide 6 equal parts. 6 not equal parts, 6 parts. How much each degree? 72 divided by 6. How much it is? 72. 72 by 6. 72 divided by 6. 12. Maintain the 12 degree and divide 6 equal parts. So 1, 2. Dividing on prime circle, not base circle, because this is a roller follower is given. 1, 2, 3, 4, 5, 6. Give the names. This is a 0, 1, 2. It is not 1, 2, 2, 2, 3, 4, 5. Again, it is being problem. 6. 6. Okay. In dual period, doing nothing. Leave it as it is. In the C to D, in this period, you are doing something. Means dividing the 6 equal parts. 6 parts. 6 parts you are dividing. Okay. So 6 parts means 180 divided by 6. 180 divided by 6. 180 divided by 6. So each one how much? 180 divided by 6. 30. 30. So before that one, Now see here, this total C2D is a 180 degrees. Now C2D here in the displacement diagram, again you have the two angles. This one 1 degree, this one is another degree. Just you calculated here. Double one 2.5, 67.5. So first one you divided 3 equal parts. Second one you divided 3 equal parts. In same manner here also you need to divide. So first measure double one 2 degree. Somewhere here it is. So show that one with the like small thin line. Okay, that is here to here how much? Here to here double one 2.5. So double one 2.5 divided by 3. The remaining how much? 67.5. So 67.5 divided by 3, because you did in the previous in displacement diagram like that only. In the same manner I am doing here. So see the triple one, how much this one? Double one 2.5 divided by 3, 37.5, 37.5, and then 67.5 divided by 3, 22.5. 22.5. So maintain that this much of degree and divide the first one. 1, 2, sorry. One, and this is the 2, this is the 3. Sorry. Now give the naming reverse manner. 6, 5, 4, 3. Again divide the 67.5 3 equal parts. This much of degree maintain 22.5. 1, 2, 3. 2, 1, 0. Okay. Now after drawing the here last one is a dual period. After drawing denoting the 1, 2, 3 on a prime circle, draw a tangent through these points to the offset circle. Draw the tangent to the offset circle through these points like this.
So whenever there is a tangent, we have whenever there is an offset circle, we have to draw tangents, no sir.
Yeah.
And whenever it is an in axis, we have to draw with the points.
Yeah. Like this, draw the tangent through these points on the prime circle, and after drawing the tangents, shift this first point to along the line, second point to along this line. Shifting means here it is the first point. I am shifting this one point to along this line. I am shifting the second point to along this line. I am shifting the third point to along this line, same line. Fourth point along this line. Shifting somewhere. How much value? The value is going to you will obtain from the displacement diagram. Okay. So see here, I am shifting the one value from the one point to along this line. How much each length? How much the length of this one? Go through that. Measure. Take the compass. Measure 1 dash. Measure 1 dash. Measure the distance with the help of compass 1 dash, and place the needle of the compass at this first point and cut the arc on this line. That is the 1 dash. Second time, measure. Take the compass and measure the distance from the two point. Two point means 2 dash. Measure with the compass and place the needle of the compass on the second point. Needle of the compass and second point, and cut the arc on the same line like this. This is 2 dash. Nothing but I'm shifting the points 2 to 2 dash, 1 to 1 dash. 3 to 3 dash, 4 to 4 dash. How I am shifting by measuring the length from the displacement diagram. Here, take the compass, measure the distance from the 3 to 3 dash. Measure the distance and place the needle of the compass at the third point. Cut the arc on the same line, that is the 3 dash. In same manner, 4 4 dash, measure the distance and place the needle of the compass on fourth point and shift the point here, cut the arc, that is 4 dash. Okay, 5 dash, 6 dash, and tangent line only you need to cut the arc, not other lines. 6 dash, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, is the one. After drawing that, this denoting the points, join the all points with the free hand. Join the all points with the free hand like this. So sorry, before joining the points,
follower banana.
roller. So that is here 1 dash. 1 dash has a center. Measure the radius of the roller 12.5. Measure radius of the roller 12.5 and draw the one circle. Here 2 dash is a center. Draw another circle. 3 dash is a center. Draw another circle. 4 dash is a center. Draw another circle. 5 dash is a center. Draw another circle. For all circles, the radius is 12.5. For 6 dash is a center, draw another circle. 6 dash is a center, draw another circle. Here draw another circle. Here draw another circle. Here draw another circle. Draw another circle. Here draw another circle. Here draw another circle. Okay. So your wish, you can draw the total complete circle, otherwise half circle like this. That you, whatever the notes I shared, in that half circles are drawn. Okay. After drawing the circles, after drawing the circles, the lowest part, the lowest curvature, whatever is there, join the all lowest curvatures. Means this is the lowest curvature of the circle, like this. By free hand, join the all lowest curvatures by free hand, not centers, lowest curvatures.
So this is for rollers follower especially.
Yeah, especially roller follower. Okay, this is the so why I'm darking here, the answer should be dark. Only the answer appearing on the paper should be dark, remaining lines should be thin lines. Remember this one. If you practice well, easily you can overcome this one. Easily you can what is this one? Base circle. Okay. Okay. If you draw with this total stationary, with the help of stationary, you can easily will get the clearly will get the answer. Okay. So this is in this diagram. This is the follower, and this is the prime circle. This is the cam profile. Okay. This is the offset circle. Smallest circle is the offset circle. Particularly whenever in question, remember this point what I'm telling now. If the question is mentioned, show the pitch point, show the pressure angle. Such situations, such statement is asking in question, that additionally you need to show. Suppose pressure angle if we asking, so draw one normal line here, This is this is the actual normal line. Draw tangent to this one. Draw tangent to this one. Angle is there. That is the pressure angle. Pressure angle is denoted by pi, not theta. It is denoted by pi. Like that, you need to show. Pitch point means pressure angle wherever the pressure angle is maximum. Okay, that is a pitch point. Actually, pitch point is may not be asked because pressure angle we need to calculate first. So to calculate the pressure angle, another relation is there that is not prescribed in your syllabus. Okay, so this is the procedure to draw the cam profile. So remember, whenever the roller follower is given in the question, you need to follow the first prime circle. On the prime circle only, whatever the operations are there, you need to perform all operation on prime circle, then construct the cam profile. Okay. Any doubts regarding this problem, Babu? And don't forget about this operation. Whenever this calculation you need to do only when this type of statement is given in the question. If the statement is not appearing in the question, nothing but these values are going to changing, Babu. These values are going to changing. Acceleration is equal to retardation. This type of statement is appearing in the question, then only you need to follow this rule. Otherwise, simple rule you need to follow.
Sir,
Yeah.
sir, that condition will be applied for which motions? I mean, which
Only
ascent
that
or descent?
condition,
How should we understand, sir?
that condition is applied for only uniform acceleration and retardation, not to others.
No, sir. One student